Welcome to all. Our interest here to describe some descriptive measures. Before giving a brief description on descriptive measures, first of all, let us define some basic concepts like variable, data, etc. So what are variables? What is variable? So any characteristic that can be measured or categorized is called a variable. Any characteristic that can be measured or categorized. For example, height, weight, temperature, income, etc. Variables may be of different types. Two important classifications. One important classification is this is continuous variables and discrete variables. Continuous variables and discrete variables are the types of variables. There are two types of variables. Continuous in the variables that can take any value within a given range are called continuous variables. Variables that can take any value within a given range are called continuous variables. For example, temperature, height, weight, etc. Discrete variables, in the sense, variables that can take specific distinct values only. Variables that can take specific distinct values are called discrete variables. Example, number of students in a class, number of cars parking in a lot, number of fishes in a lake, number of accidents at a particular place, number of defectives, etc. like that. Now, another important concept I have to define is data. Data is quite relevant, important. Data in this is also connected to the variable. So, a set of individual observations pertaining to a given variable under study. Set of individual observations pertaining to a given variable under study are called data. Or it may be organized or unorganized. Data may be organized or unorganized. Organized in the sense arrayed. Okay, there is some arrangement. We make it in some arranged form. For example, arranged in ascending order or descending order. Arranged in descending order. Whereas unorganized data are nothing but raw data. While we collecting a data, we get in the unorganized form. That is the raw data. For example, while we conducting an experiment, we through that experiment, simple pendulum or like that, some experiment, we collect the data in a raw form and we thereby we make it in a arranged form. Or we conducting a survey, we have some survey results first in the raw form, raw data. Also census data, while another example of data. Now data are again different types. One classification is qualitative data and quantitative data. Qualitative data in the sense non-numerical data. They are non-numerical data that describes the characteristics or qualities. For example, colors or gender, male, female, like that, gender, like that, different non-numeric data or qualitative data. Whereas quantitative data are numerical data that can be counted or measured. So numerical data, quantitative data, numerical data, but qualitative data, non-numerical data. For quantitative data, example for quantitative data, heights of students or number of books in a library. All these are, we can either measure or count it. So these are non-numerical, numerical data or quantitative data. So The, now, once we have data or raw data, we can make it in some tabular forms or make it in systematic arrangements. One of them is discrete frequency distribution is quite important here. A tabulation, discrete frequency distribution in the sense, it is a tabulation of data values showing frequency in the sense number of occurrences of each distinct value. Each distinct number of occurrences of each distinct values or frequency of each distinct values. For example, number of books read by students in a week. So here number of books maybe say 0, 1, 2, 3, etc. So there are 5 students who read 0 books during that week, and 8 students read 1 book in that week, like that. Whereas another is grouped frequency distribution. Here frequency distribution, a frequency distribution where data is grouped into intervals. Grouped into intervals in the sense, let us consider the example of heights of students. We can make in groups. So height in 150 to 159 centimeters. So there are 3 students. 3 students belongs to that group. And 7 students belongs to the next group, that is 160 to 169 centimeters, like that. So this is a grouped frequency distribution. And there is a continuous frequency distribution. A frequency distribution where continuous data is grouped into intervals. Continuous data is grouped into intervals. We have already mentioned temperature is a continuous variable. That we can temperature readings over a period. Let us consider temperature readings over a period. Now temperature we can classify to 20 to 25 degrees Celsius. There are 15 days have temperature in between 20 to 25 degrees Celsius. And the 20 days have temperature in between 25 to 30 degrees Celsius. Note that here 25 we have excluded from this group because it is the upper class limit. Upper class limit is excluded from this class and included in the next class. So that 24.99 something, whatever we can include there in this class, but 25 included in the next class. Here we have for example 20, 30, 45, 50 days are there. So not a month, we have a period. So during this period we have collected the temperature data on temperature, and we found that temperature, there are 15 days have temperatures in between 20 to 25, like that. So this is the frequency distribution. Now let us think of averages. So what are the important objectives of averaging? Important objectives of averaging are: 1, summarization, representation, comparison, decision making, and simplification. Summarization. What do you mean by through that word summarization? Summarization in the sense providing a single value that summarizes a set of data points. It provides a single value that summarizes the set of data points and making it easier to understand and compare it. Whereas representation is to represent a typical value of the data set, allowing for generalization about the data. That's a representation. In comparison means to facilitate comparisons between different data sets or groups by providing some value. So we have 2 or more groups. We have to compare these groups. For example, marks of different students in different classes for particular subject. We need to compare. So we need some sort of averages there. Now decision making is another important objective, to support decisions by providing an overall measure of the data's central tendency in order to assess the trends and make predictions and for making predictions. And another important aspect is simplification. Simplification in the sense to simplify complex data into more comprehensible form, aiding communication and interpretation. So in order we have a complex data, huge data or different types of data are there. So we need to have a representative or typical value that represents the data in a simple form. So that these are the important aspects, the important objectives of averaging. So what are the important objectives? One is summarization, another is representation, another is comparison, another is decision making, and simplification. These five important objectives are there behind behind obtaining an average. Now we have to think of, once we have an average, whether it is a good average or not. What are the characteristics that should be satisfied by a good average? So the desirable properties or the of an ideal average or a good average are: one, it should be rigidly defined. This is important. One, it should be rigidly defined. Second aspect is it should be easy to understand and compute. So it should be rigidly defined. It should be easy to understand and compute. It should be based on all the observations. Then only it is a representative of that data. It should be based on all the observations in that data. It should be suitable for further statistical computation and processing. It should be suitable for further statistical computation and processing, or it should be amenable for further mathematical treatments. So it should be rigidly defined, it should be easy to understand and compute, it should be based on all the observations, and it should be suitable for further statistical computation. And another two important aspects, it should not be affected by fluctuations of the sampling. And while we have collecting data, there are different fluctuations of the sampling through sample surveys, etc. It should not be much affected by fluctuations of the sampling. Also, it should not be much affected by extreme values. Sometimes certain extreme values, we call it as outliers. So these extreme values affects the typical representation or the average. Then the average will not be a good average. So the average is a good average should not be much affected by extreme values. So these are the six important or desirable properties of a good average or an ideal average. Now let us define different types of averages. For example, different types of measures of central tendency: mean, median, mode, geometric mean, harmonic mean, etc. Let us define them one by one in the next class. Okay. Thank you all. Thank you so much.